Dear ladies and gentlemen, greetings. My name is Xiaoyu. Today, I'm going to do a presentation about my work in the customer service text label recognition. In this research, I proposed a method which is based on sentence-level pre-training technology. Now I will begin my presentation. My presentation mainly includes 4 parts, which are listed in this slide. The first part is about introduction, consisting of background information and research aims. The second part is about previous related work about my research topic. It consists of selective machine reading comprehension technologies, and machine learning and deep learning models introduction, and abstractive summarization technologies. And the third part is about techniques I used in my research. It includes T5 model, GSG technology, and the T5 Pegasus model. The last part is about experiments, consisting of GSG sentences datasets and ERNIE model building. So let me start. The first, I will talk about the introduction part. I divided this section into 2 parts. The first one is about why I conduct this research. Since customer service tasks contains a lot of information, including user preferences, user intentions, and some users' information. So making good of this information can contribute a lot to refining the service system, then provides better service for customers. Besides, the user attribute tags, which stands for the user's preferences, it can be quantified. Recognizing users' attribute tags can better study the user's preferences in purchasing goods, selecting financial products, and in other areas. But how we can solve this problem? This task can be solved by building machine reading comprehension models. And this model accepts article questions and choices as input, then imitating the human beings doing the reading comprehension task, choosing the right answer from the given choices. However, there is something difficult in answering questions about users' intentions and attitudes. And answering these questions needs the ability to grasp the full text information and extract users' feelings and attitudes. So to solve this problem, I used the sentence-level pre-training technology to train the model understand the full text information, then better answer this type of question. Then I will talk about aims. First, the ultimate aim is to train the model to grasp the full text information. Then, using abstractive summary generation technology to generate the summary of customer service texts. The building a summary generation model using the ERNIE model, which will be used in the following machine reading comprehension task. Then train the model to generate the summary of customer service tests and sum it into a data set. Then use the train the ERNIE model to build a machine reading comprehension model to grasp the full text information. Finally, the test results showed that the proposed sentence level pre-training technology can effectively improve the model's ability to extract customer service test user attributes. Then I will talk about the related work. The machine reading comprehension text is based on human beings' actual reading text content understanding and answering related questions. In this task scenario, the machine will accept the input article content, question content, and option content to answer questions and give answer options. The selective reading comprehension can choose a most suitable answer from the alternative options based on the given article content, question content, and option content. At the same time, the selective reading comprehension task includes a lot of reasoning and inductive tasks, combined with external common sense, which can more comprehensively grasp the full text content. There are some datasets for selective reading comprehension, such as CLAUS, OpenBook QA, RACE, and C3. In addition to providing articles and questions, the OpenBook QA also provides an external knowledge base for answer selection. When answering each question, the answer is selected by combining facts of the internal knowledge base. Therefore, when using this dataset, in addition to dealing with the data integration, it is also necessary to accurately utilize the external knowledge input into the model. And the RACE is currently one of the most widely used selective reading comprehension datasets. It consists of high school English reading comprehension questions. The RACE dataset contains many complex questions involving text content understanding and reasoning. There are roughly 5 types of reasoning questions in it, which are detailed reasoning, article summary, global reasoning, basic common sense, and attitude analysis. So it can effectively evaluate whether the reading comprehension model has the text reasoning ability and can evaluate the ability of the reading comprehension model. Finally, the C3 dataset is a Chinese reading comprehension dataset. The articles come from the content of the Chinese proficiency test and the national Chinese test. It collects the multiple choice questions in a more flexible form. The data is divided into the formal written test and oral test. The data samples are short tests, so they perform poorly when training on long test tasks. And based on the above datasets, there are more reading comprehension models based on neural network structure. Currently, the most widely used pre-training model is the BERT model. The BERT model was open sourced in 2018. It uses a bidirectional transformer and an attention mechanism to train a language understanding model, and uses a random character mask to understand the semantics of text fragments. And another model called the DCMN Plus, which is a method for multi-choice reading comprehension model, the dual co-matching network model, and other models such as the magnitude BERT model, Albert model, the XLNet model proposed by Yang, and the Robot A model proposed by Liu, also have a good performance for different downstream tasks. The ERNIE model is Baidu's the open source high performance task understanding model in 2019, adding the masking technology for phrases and entities on the basis of BERT, and adding continuous multitask learning technology, which has a strong comprehensive ability in task analysis, task solving. And in this research, I chose ERNIE model to build a machine learning comprehension model. Also, there are lots of abstractive summarization technologies, such as MAS, UniLM, T5, and Paxos. MAS uses the sequence-to-sequence structure and masking strategy to predict the next content. UniLM uses the masking technology. When solving the NLG problem, it uses the first part of the task to predict the next to train the model. The T5 model considers every NLP task as the text-to-text task. And Paxos uses sentence-level masking to predict the following content. Then I will talk about the techniques used in my research. The T5, which is short for the text-to-text transformer model structure, is still an encoder-decoder structure stacked by transformer layers. The decoder structure is very similar to the encoder structure. but the decoder has a standard attention layer after the self-attention layer. And for unified modeling, all tasks are converted to a text format, and the model is optimized by maximizing the likelihood objective, keeping the goals of the pre-training and fine-tuning unified. To let the model know what task it is performing, then prefix the input task with a task-related prefix. Then the authors found that the changing the word of the prefixes had a little effect on the results, so the effect of different prefixes was not explored. The T5 model architecture adopts the encoder-decoder architecture, and the mask method adopts the part without the mask and the part with diagonal marks. The difference between different models is mainly in the mask design in transformers self-attention. Some without marks, some with diagonal marks, suitable for sequence-to-sequence languages, such as encoder-decoder model. The output sequence in the encoder and the previous token in the decoder will participate in the attention calculation of the following tokens. And about the T5 model's significance, the T5 model has great significance in evaluating the models in different NLP tasks. First, it considers every NLP task as task processing task, and it provides a unified way of evaluating the efficiency of different models by just solving task-to-task tasks. Then talk about the GSG techniques. It is different from traditional method of masking words, MLM. The MLM is short for the masked language model. In this model, some content might be randomly masked and replaced by the mask symbol. Then the model should predict the original content through the context. In the BERT model, the masked part is made up of two symbols. 80% is replaced with a special mask, and the 10% is replaced with other random words, and the remaining 10% is left unprocessed. This condition is different in another pre-training model, but GSG is different from this model. It is assumed that the closer the pre-training target is to the downstream task, the faster and better the fine-tuning effect will be. Therefore, the more semantic relationships can be learned, and by randomly masking out some sentences, the relationship between the sentences can be understood, and the new text content can be generated through the relationship between sentences. To this end, the downstream language task is described as extracting text summarization, while the pre-training goal is to generate the interstitial sentences. In the actual experiment process, some single sentences in the original text are directly masked. Then, the remaining gap sentences are directly biased as the text cited summary. The masked sentences are replaced by the mask symbol. In order to get closer to the fine-tuning of the downstream task, we will select more important sentences in the article for masking. And the GSG techniques uses three strategies to select gap sentences. The first one is randomly select. It just uniformly randomly select M sentences from those sentences. And the second one is lead. It select the first M sentences from the unchosen sentences. And the third one, which is used in this technique, it's just like principle, and it selects top 5 most important sentences according to the importance. About the principal way to select the gap sentences, there are 4 divided ways to select. The importance of the sentence can be calculated by the ref1 f1 value of the chosen sentence and the other sentences. After calculating all the values, choosing the top 5 highest value as the chosen sentences. The third and the sequence one by maximizing greatly choosing the sentence set and other sentences ref1, roach1 f1 model. And the unique one is to remove the repeated n-gram first and then calculate the roach1 f1 value. The origin one is to keep the original sentence set and do not remove the repeat n-grams. And about the T5 Paxos model, it adds the word segmentation function to the burst tokenizer, improves the word segmentation table, and as the first one as the first 100,000 words after stuttering the word segmentation to the original Chinese bird character token dictionary, and then modifies the internal structure logic of the tokenizer so that the tokenizer can segment the vocabulary. And also it designs a new pre-training sample construction method for documents through a search strategy. A certain number of target sentences are selected and use the remaining sentences as sort sentences to do the sequence-to-sequence task. The final part is about dataset generation and ERNIE model building. First, load the capital content of the customer service test dataset and pass it to the T5 model as an input to generate a summary of the chapter content, and edit and construct a summary dataset according to the article number. Then train the ERNIE model based on the text summary dataset and build a test summary model built based on the ERNIE pre-training model. The model training process uses the text content as the task input and then the summary content as the output. In the T5 Paxos paper, GSG is used to generate gap sentences. It mainly considers sentences that can be extracted as a set of summary. Some important sentences are selected instead of MLM text, similar to the BERT model, and some words masked and randomly selected. Then the model ERNIE is trained to be able to grasp the full task information. The model is trained on the abstractive text summary dataset. Then the pre-training model is used to build a machine reading comprehension model, and consisting of encoder and decoder. The pre-trained ERNIE model is wrapped as the encoder of the model. Then train the model to solve the selected machine reading comprehension problem. The result is shown in the right table. We can see from the table that the proposed machine reading comprehension model with the sentence level pre-training, which is called ERNIE A, has better performance on C3 datasets and customer service text datasets. So the effectiveness of the method is proven. That is the end of my presentation. Thanks a lot.